I wrote a C text editor that can run games in it. The game that I wrote to test the workflow out is Tetris, the workflow that ended up blowing my mind. So piece this together. You see the code and the frame buffer with the result all on the same screen, on the same canvas. The canvas which you can move around as you please. The editor's API and its whole state is exposed to code running dynamically inside the editor, so you can do anything you please by just writing C. Does hearing this ignite the same excitement that it does in me? Excitement about starting numerous game projects and never finishing them, without messing around with plugins, unfamiliar languages, dot files, badly documented JSON configs, systems, utilities, and the rest of the chain of tools. So how does this all work? Actually, it's pretty simple. All the dynamic code stuff is done using dynamic libraries. Let's see how it works by writing a little hello world program. Then writing the build script, still in C. Notice how there is no build system to speak of. It's just C with some helper functions. For now, hello world is just printed out to standard output, which you see in the shell, as it's running as a separate process. But just imagine if it's all piped back into the editor itself, and you could treat that output like any other text buffer. So that is what I call a scratch buffer. It can run any code you please, as long as you don't crash the editor, that is. But that comes with the territory when you have such immense power. It can even change things in the editor itself. The whole API is your oyster. Now, let's talk about live scenes. In essence, it's just an OpenGL frame buffer plus a dynamic library. Every frame, the editor asks the live scene to render to that frame buffer and then displays the result. Let's take a look at this example of a simple triangle being rendered with a 3D flyby camera. You can capture the input so that the live scene takes exclusive control until you hit a hotkey to return the control to the editor. It has hot reloading, so it works very nicely with the scratch buffer used for building, as you will see the rebuild scene instantaneously. On top of this, your application is not tied to the editor, it's just a dynamic library written in C, and the editor's own platform layer can run any live scene independently. So by starting your live scene with a platform layer, you will have a completely standalone app in its own process, still with hot reloading, etc. Plus, the editor itself is a scene that adheres to the same interface as any other live scene. And so, you can run the editor as a live scene inside the editor. Or you could, until I broke it and got too lazy to fix it. Here's a screenshot. So let's get to our Tetris. To begin with, I'm introducing some helper code. It's just some basic header files I will be using in the project. Platform types contain some structs that the platform or the editor passes to the live scene, containing events such as key presses, timing info, etc. Common just has common types, some linear algebra, and stuff like that. And GL glue just wraps around some GL calls to make life a little easier. Let's convert our Hello World program from a standalone executable to a live scene target. That's pretty simple to do. Let's replace our main function with some function stubs that the editor expects, and let's just clear the frame buffer to a certain color every frame for now. Then let's modify our build script to build as a dynamic library, linking with OpenGL and GLFW. Fix some compilation errors, and then open the dynamic library as you would any other file. You can see the frame buffer being cleared to our color. You can also rebuild it on the fly and see the results instantly. Now it's time to draw a triangle in this frame buffer. Let's store frame buffer dimensions in our state that we will use for our matrices and the viewport. Let's also type out a basic shader program for colored 2D shapes in orthographic projection. Use the program and push the projection matrix uniform. I have this very simple framebuffer API in GL Glue where you simply push vertices into it and then issue a draw call. It's very simple but useful in these early stages. Let's use it to draw the triangle vertices. Just fixing a bug in the editor real quick. And there, we got our triangle. So, let's focus on actual Tetris specific code now. First, draw the canvas background. Just two quads, a darker one behind, a lighter one in the front. Then let's draw the blocks. Again, just two quads, darker and lighter. And finally, let's draw the blocks in the proper 10 by 20 Tetris grid. Then, let's write the code that will allow us to render the actual Tetris pieces, with rotation. I opted for this piece spec struct, where I specify the color and which blocks are lit up relative to the top left corner of the piece. For rotation, I simply swap and flip the x and y coordinates passed into the function that checks the state of the block in a piece. After fixing some issues with the T piece, I write out specs for all the other shapes. So here are the 7 pieces. Next, let's get the pieces falling. I committed too soon to committing too soon the pieces into the actual grid behind. I realized while the piece is falling, it still needs to be manipulated as one whole piece. Only after it lands can it be committed to the grid. So while the piece is falling, it is handled separately from the rest of the grid. I stored the struct of the current piece in the state and wrote some drawing code separate from the block grid. I then added a timer for the falling piece. Every period of the timer, we're moving the piece down by 1. Of course, we also need to check collisions, for which I just check if any of the lit up blocks in a piece overlap with an existing block in the grid. If it does, the movement of the piece fails and the outer code commits the piece to the grid and replaces the current piece with a new one that gets placed at the top of the screen. Next, I randomize every new piece's shape and rotation by simply using the standard libraries rand, nothing fancy. Next, player controls. Very simple. When the up key is pressed, I rotate the piece to the right. Left and right keys slide the piece to the sides, and the down key increases the move period while it's held down. I also added some simple logic to stop fast movement when a piece is committed. You can see here, by the way, that in the end of the day, it's just GLFW key press info that is passed along in the platform events. So there's no separate API or notation to learn here, just good old GLFW. I reused the same collision check code to prevent generating a new piece if it would cause a collision. This also serves as the game over condition. Next, destroying full lines. I just wrote a function that will find the lowest full line and another one that will keep deleting the next lowest full line and sliding all the pieces one cell lower until there are no more full lines. And now you can see pretty much the actual gameplay. The last thing, let's just dim the pieces to indicate that the game is over, so I don't have to write any text rendering and UI rendering code. And let's prevent further processing until any key is pressed, at which point the game state is reinitialized and the game starts over. A few tweaks later, we have the finished game. Pieces fall down, lines get destroyed, Tetris gets played. And as I mentioned before, at any point the game can be started as a standalone process, using the editor's own platform layer. Here it is running independently. This is the kind of game development cycle that gets me excited.